Okay, good afternoon, everyone. Thank you for joining us for our professional and career development seminar series today. This is the fifth seminar out of six we are conducting in this whole semester. And if you attend four out of six, you get a micro-credential badge or certification for the professional and career development program. So, I am Madhumita Joshi. I'm director of the postdoctoral success at graduate school and at UTSA. And I'm today honored to introduce our guest speaker, Dr. Ramin Sahba. Dr. Sahba is not only faculty at UTSA, but he is also a UTSA alumni. So Dr. Ramin Sahba is an assistant professor of instruction in the Department of Computer Science at UTSA. Uh, Before joining our computer science department at UTSA, he worked as a visiting assistant professor in the Department of Computer Science at Sam Houston State University. He has a PhD and master degree in electrical and computer engineering from UTSA and a bachelor degree in computer engineering from Chicago University in Iran. So he is really our UTSA um, alumni and a long connection with UTSA. So
Yes.
his research interest lies broadly in AI and machine learning, data science and big data, deep learning, image processing, and NLP and Internet of Things. So we welcomed our guest speaker, Dr. Ramanai, and thank you for accepting our invitation and joining us to share your deep knowledge in data science and artificial intelligence. Yes.
Thank you, Dr. Mathimita. Uh, okay, yes, as Dr. Mathimita introduced, I'm Ramin Sahba, and I'm going to uh, provide a presentation today for you guys about data science and AI in general. You may have different backgrounds with different level of knowledge relating to data science, AI, deep learning, machine learning. But I'm going to talk in general about data science, what is data science, and how actually uh, we can define data science, what are the different aspects in data science and AI, and actually what are the applications of data science. So first, let me share my screen. Okay. So actually, data is all around. We have data everywhere. Lots of data is being collected and warehoused. Actually, warehouse in this term means collecting data and transforming data from the raw state of data to something useful to actually structure data, right? There are different kinds of data, or we have data in everywhere. For example, we have web data, we have, or for example, e-commerce, right? Also, we have data like financial transactions, right? Can be happen through the internet, right? Bank or credit transactions, right? Online trading and purchasing. When you buy something through internet from, for example, from Amazon, right? You are using data and also you are generating data, right? Social network. When you are uh, actually, when you chat with your friends on social media, different social media, right? When you have a video meeting, right? These are again using examples of using data and generating, also generating data, right? We have medical data, we have education data, right? So many kinds of data, and they are all around us, right? We are using them, we are generating them, right? This diagram shows growth of data uh, from 2002 to 2015, and we can see how fast it is growing and what is the amount of data generating and producing each year. So here, as you see, in 2002, we had about 5 exabyte of data generated during that day, right? That year. But let's first see what is an exabyte of data, right? You may have been familiar more with, for example, 1 TB of data because, for example, your laptop maybe have a hard drive of size 1 TB, which is 1,000 GB, and it has a large space to store many documents, many movies, videos, right? Many music files, right? For example, my laptop has a 1 TB hard drive, and I have my laptop for a couple of years, and still more than half of the space of its hard drive is empty. I have lots of data on that, but still have uh, space to add more data, store more data. So 1 TB is 1,000 GB. 1 PB of data is 1,000 TB. Suppose you have 1,000 of those hard drives, right? That is a 1 PB. And 1 EB is 1,000 PB of data, or 1 million terabyte of data, right? Okay. So in 2002, 5 EB of data were generated. What is the human brain capacity? You can see that 14 petabyte is actually the human brain's capacity, which means you can store in your brain data that can be stored in 14,000 1 TB hard drives, right? So as you see, uh, the capacity of a human brain is very actually a very large capacity, 14,000 terabytes, right? Okay. And what is, for example, data that was generated in 2006? You can see from 2000 to 2006, only after 4 years, from 5 EB of data, we generated 161 EB of data. Actually, uh, more than it's almost more than 20 times, right? More than 20 times we generated data just by passing 4 years, right? Okay, and then you see, for example, we can store 100 years of HD videos plus the audio by using storage that has 60 petabyte, right? 60 petabyte, right? So, however, in 2011 or 2010, 2011, we almost generated 2 zettabytes of data. Each zettabyte of data is 1,000 of exabyte of data, right? And in 2015, about 9 years ago, we generated 8 zettabytes of data. What do you think about last year, about 220, 2023? How much data was generated during last year? What is the slope of this actually increasing of the amount of data? Okay, let's see. Approximately more than 300 million terabytes of data are created each day, right? Each day, this amount of data is created, right? Around 120 zettabytes of data will be generated this year, which is 2024, right? 181 zettabytes of data will be generated in next year, 2025, right? Compare this with 2015. From 8 zettabyte of data, next year we'll have more than 180 zettabytes of data. So the growth of data that is generating is very fast, right? We have a, term, a very large amount of data generated every year, right? The interesting point is that videos account for over half of the internet data traffic. And approximately more than 50% of the internet data traffic is just for videos, right? In US, just in US, we have over 2,700 data centers, right? Each data center can store a large amount of data. And as you see, approximately 90% of the world's data was generated in the last 2 years. 90% of the world's data, the whole data generated, actually from the time we could record data, we could store data, 90% of the whole data generated so far is just generated into the last 2 years. So you see the fast growth of data, right? In the space of only 13 years, this figure has increased by an estimated 60 times from just 2 zettabytes in 2010. If you look at this diagram, from 2011-10, we had about 2,002 zettabytes of data. Now, next year, we will have 181 zettabytes of data, right? Okay, and you see in 2003 to 20, sorry, 2023, we had generated 120 zettabytes of data, but that will be increased to 181 zettabytes of data in next year, which is over 150% increase in generating data. So what we should do with this amount of data, this tremendous amount of data, right? Okay, in that diagram, in this diagram, again, you see visually you can see the increase of data that is generated, right? And as you see, that is exponential growth or increase, right? It's not constant. The increase is not constant. It's exponential. So we can see how fast we are generating data. And again, as you see, more than 50% of the data that is generated is video data. Okay, actually, data is like raw oil, is the new oil, right? That phrase is not a new phrase. Actually, it was uh, told in beginning of 21st century that data is the new oil. Why? Because it's valuable. But actually, like oil, like raw oil that needs to be refined uh, to be able to use that in different aspects, different applications. Data, the raw data cannot be used, right? Just the raw data is not valuable. We need to clean data. We need to uh, refine data. We need to actually um, make structured data, right? We need to analyze data, right? We need to organize data to make it valuable, to be able to use it, to turn it to data product, right? But it's so valuable. So what is big data? Any data that is expensive to manage and hard to extract value from, right? That is called big data. We have three different aspects in big data. Volume, the size of data. So in big data, the size of data is very high. We have a large amount of data. Velocity, which means the latency of data processing relative to the growing demand for interactivity. Sometimes we may have enough data, right? But however, to process them for example, the required task or required goal, we need to process it as fast as possible for that goal, right? For that goal to be reached, right? However, if the processing time is high, we have an amount uh, or large amount of data, and we need to process it to generate useful data product. But if it takes a long time, maybe it's not needed anymore. Maybe we cannot reach the goal, right? So it's very important to be able to process data in an amount of time that is uh, um, actually that can be considered as a satisfying time for to reach the goal, right? Also, we may have variety and complexity of data, right? The diversity of sources, we may have different sources. For example, you may get data from, from, for example, social media from internet, right? Or you may get data from sales of a company, right? Or you may get data from transactions from a bank, right? From bank account, right? So we may have different sources of data, different formats, video, text, audio, quality, and structures, right? We may have different structures of data. Okay, so in that diagram, you see these three aspects in big data. Data velocity, we can have real-time data, right? The data that is generated at real time and need to be processed at real time. For example, an autonomous car, right? When you have an autonomous car that gets information from its sensor at real time and needs to be processed at real time to, for example, prevent uh, hitting an obstacle, right? Prevent hitting a pedestrian in the street, right? We may have near real-time data, uh, so it needs to be processed, maybe not exactly real time. We may have periodic data and batch data. The volume of data can be from kilobytes, megabytes to a lower amount of data, terabytes and petabytes, right? That needs to be processed. And different type of data, right? Data variety. For example, marketing automation, CMS, audio, video, web, photo, right? Mobile app, right? Different type of data. Okay, these are examples of different type of data that we can have. Relational data means data that we, for example, can organize them in tables, right? Or transaction data or legacy data. These are called relational data. Text data, many data, uh, I mean the many kind of data that you can get from web or among text data, right? Semi-structured data like XML, if you are familiar with XML, a format that can be used to store data, right? Graph data, social network data, semantic web data, or resource descriptive framework data. This is a kind of data for specific format of data for semantic web data and also streaming data. Some kinds of data that we have, right? But what to do with these data? We have a large amount of data in different types. Some of them needs to be processed real time, some of them near real time, some of them can be processed offline, right? Okay, so we can do aggregation and statistics, right? For example, data warehousing and online analytical processing. Online analytical processing or OLAP is actually a um, category of software tools that are used to analyze business data, analyze data for businesses. It's called OLAP. And data warehousing, as I told uh, earlier, means transforming the raw data or unstructured data to structured data that can be used, right? Or, or organized data, right? Indexing, searching, and querying is other things that we can do with data, right? For example, keyword-based search or pattern matching, right? Pattern matching is another kind of search, for example. Knowledge discovery. We can discover new knowledge from data, knowledge that was not exist before. But from the data that we have by doing data mining or statistical modeling, or some other methods, we can discover new knowledge from data that we have, right? Generate knowledge, right? Okay. What is data science? Right? We learn about the amount of data that is generated, the different kinds of data, right? And what can be uh, actually extracted from data. What is actually data science? It's an area that manages, manipulates, extracts, and interprets knowledge from tremendous or vast variety or amount of data, right? Can be structured data or unstructured, right? A structured data, let's give an example. A structured data means when you have records that all of them almost have the same sizes, have the same fields. For example, a record of information of the students. For example, ID number, first name, last name, birthday, major, right? These are when you put these information for each student in, for example, table. So that is called example of a structure, right? But unstructured data, when you have sensors to get data, for example, data from weather to forecast uh, weather for example, next day or next week, right? The data that you get from sensor, the raw data, for example, temperature, humidity, right? Pressure of the weather, right? When you get from sensor, collect them, those are unstructured data and needs to be structured, right? Okay, so when we have data, we need to clean data, manipulate data, extract them first, right? Uh, Transfer them from one kind to another kind, from unstructured, transfer them to structured data, right? So all of them are techniques that are actually considered in data science, right? We can also say data science is a multidisciplinary field of study with goal to address the challenges in big data. However, data science principles can apply not only on big data, any actual size of data, small data, big data, right? Okay, so as you can see here, there are different techniques and theories uh, in data science, right? Theories and techniques from many fields and disciplines are used to investigate and analyze a large amount of data. But for what? To help decision makers, managers, uh, in, for example, companies, the engineers, right, to make decisions, right, based on data that they have. Why? For example, to increase their profit, to provide a better product, right? To predict what happens, for example, in the next 5 years, 10 years, right? So, um, investigate and analyze large amount of data to help makers in many industries, such as can be many different fields. For example, science, different kind of science, biology, psychology, right? Or finance, right? Engineering, economics, politics, education, and many more. For example, medical sciences, right? Can be used in any of them. Uh, Actually, the techniques or algorithms that are generated or used in computer science and are layered in computer science, many of them are used in data science. They can be pattern recognition, visualization, data warehousing, high performance computing, databases, AI, and uh, actually some more uh, techniques in computer science that can be used for data science. Or in mathematics, for example, many mathematical modeling we use in data science, right? We need to model, for example, how data is changing, right? Or how data is generated, right? Also, many concepts in statistics are used in data science. For example, statistical and stochastic modeling, right? Probability. These are concepts in statistics that are used in data science. So if you are going to be a good data scientist, you need to be a good or have a good knowledge, experiment in statistics, and probability, mathematic modeling, and uh, you need to get familiar with different techniques, algorithms, methods in computer science, like pattern recognition, high performance computing, AI in general. Okay, as I told before, data science is multidisciplinary, right? In this diagram, you can see that different actually disciplines are um, used in data science, right? Again, you see, for example, statistics, visualization, data mining, you see here, AI, right? You see, AI doesn't mean data science. Actually, AI has methods, tools that can be used in data science to extract data, to clean data, to actually find missing data, to organize data, to transfer data, to, to generate useful data from raw data, right? The elements, the techniques in AI can be used in data science. Actually, a part of AI is machine learning. We'll learn more about machine learning in this presentation, but machine learning is a subset of AI, which actually includes some techniques, some algorithms that can enable a machine to learn new things from data, right? The machine learning techniques also can be used in data science. Um, if you have, guys, if you have questions, you can interrupt me and answer your questions by uh, typing in the chat box, or you can open your mic and ask your question. Don't be shy. So this diagram again shows the different disciplines that can be used or affect data science. For example, data engineering means manipulating data in a way that we can use the data, can be useful, right? Scientific methods are used in data science, math, domain expertise, hacker mindset, statistics, visualization, and advanced computing. All of them can provide tools to be used in data science. But in general, what is data science used for? Right. Okay, data science is used for a wide range of applications, right? You can find actually in any discipline, in any major, you can in any field, you can find applications for data science. Why? Because we need data in many aspects, right? In many fields, and we need those data to provide to um, turn them to useful data, right? We have raw data. We need to extract useful data. We need to turn them to something that can be used as a data product. For example, to increase the performance, to um, to increase the sale, for example, um, to predict, right? To categorize data, right? Sometimes you have raw data and you need or data items and you need to categorize them in different categories, right? How to categorize them. Data science techniques can be used to categorize data. Sometimes you need to find patterns in data, right? You have data and you need to find patterns in data. I will talk about that later. So these are some applications, right? Example of some application. Predictive analytics, right? To predict what will happen, for example, in next day, in next weeks, in next year, right? Machine learning, data visualization, recommendation systems. Many companies are using recommendation system, right? To help them uh, recommend, for example, what product needs to be uh, produced more. One kind of customers need to be focused more, right? Fraud detection, sentiment analysis, decision making, right? To help managers, engineers, uh, decision makers to actually to make better decisions. in a various industries, they are used in a different kind of industries, aspects, fields, majors. For example, they are used in healthcare, finance, marketing, technology, and many, many more. But what is the goal of data science? Uh, in general, we can say actually the goal is turn data into data product, which means we have data, raw data, but we need something to get something useful from that data, right? So we need to turn it data products, something that can be used, that can help us to, for example, predict the future of the market, that, for example, can help us to make better decisions, can help us to find patterns in data, for example, to discover patterns in data or uncover the hidden patterns in data, right? Let's see some real life examples of data science. Companies learn your secrets when you shop. For example, you many of you may uh, do online shopping, right? You may buy uh, from Amazon, from eBay, or many other uh, websites that um, sell online products, right? So companies can learn your secrets from shopping patterns, right? And preferences. There is example here that is actually a real example that was um, considered as a case study in one company. For example, can we know if a woman is pregnant, even if she doesn't want us to know, right? Again, this was actually a case study for a company, but based on behavior of someone, for example, shopping behavior of someone, the goods that he or she is interested in, right? Or even in social media based on messages that he provides based on, for example, reviews that he or she provides, right? In social media or in that website for example, um, um, somebody buys something from a company, right, from an online website, and then provides a review for that. Even from that review, that company may get or uncover some secrets about that person, right? So it can find patterns and actually uncover patterns from those data and uh, find some secrets or learn something that the person even may not want the company to know, right? But it happens, and always it's happening for us, right? You may have experienced a situation that you were thinking about something. For example, maybe you were thinking about buying something or doing something, right? Maybe not just buying something, you're doing something, right? And you never talk to anybody about that, right? About your idea or what that you are going to do, right? But after a while, when you are, for example, searching video or searching internet, right? Or when you are in social media and uh, there are where that you can see some, for example, advertisement. You see advertisement that provides actually uh, goods or some products that are useful or can be used in what you are going to do, right? For example, you are thinking to travel, for example, to Hawaii, right? And you want to have some fun there, and but you didn't talk to anybody. But when you are, for example, searching web, or for example, you go to Amazon to just buy something for your kitchen, but you see there are advertisement or products are suggested to you to buy that is related to your travel, to the idea that you have, right? how they would find that you are going to travel. You didn't talk to anybody, but because of your behavior, because of actually the web pages that you looked at, you searched, because of the um, mm, text that you provided, the reviews that you provided, because of the advertisement that you focused more on them, right? You took more time to watch them because of the products that you buy. They can find those secrets, right? Or let's provide another example. Suppose that um, you are going to buy some gardening tools, right? You're going to buy some gardening tools, and then after that, you see that uh, the website is also suggesting you some outdoor kitchen, right? Why? Because it predicts that you may need outdoor furniture. Sorry, outdoor furniture. Why? Because it predicts that you are going to enhance the garden, the backyard, and then so you need to go out and enjoy your garden, your backyard. So you may need uh, outdoor furniture, right? So from the data that you provide, they can make decisions. They can actually predict, right? Predict what is needed for you next, right? Data science is also used vastly in election. Many elections now are using data science. For example, to localize the advertisement, right? What kind of advertisement is best for people that live in Texas, right? Or also they can provide better actually advertising text for people that are um, um, going to vote, right? So in many elections, data science are used, and not just in the US, many other countries also use data science in politics, actually, not just for election. Some other examples, marketing, predict the characteristics of high lifetime value or LTV customers, which can be used to support customer segmentation, identify upsell opportunities, and support other marketing initiatives. Example again, as I provide for you, what can be, for example, based on uh, the products that a customer buys, what can be a product that she or he may need later, right? So they will provide advertisement including those products, right? Logistics. Forecast how many of which things you need and where will we need them, right? Which enables learn inventory and prevents out of stock situations. So, for example, Amazon has uh, mm, warehouses in different cities to make it available 1 day delivery, right? 1 day delivery. So how they could find which goods, because they cannot put all the goods all the products that they sell in the warehouses that they have, right? But they actually analyze data, they extract, clean, organize, and actually get useful data from the vast amount of data that they have. And they realize that these type of the goods, these type of the products are the products that people need fast. They need them after they order them, they need them fast. Maybe just in 1 day they need them, right? So they provide those kind of data in their warehouses, right? And they make sure that uh, it's not that there's no out of stock situation for those products. The other field is healthcare. Analyze survival statistics for different patient attributes. For example, attributes can be age, blood type, gender, etc., right? And for example, treatments, right? Uh, to have a better treatment, predict risk of readmittance based on patient attributes, right? If this patient is readmitting again or not, right? What is the risk of readmission for this patient based on the data that uh, the patient provides, right? Medical history, etc. These are some more examples. Transaction databases, for example, recommender system, the Netflix that recommend you based on the movies that you watch. It recommends you new films to watch. Fraud detection, wireless sensor data, for example, for a smart home when they gather data, different data, for example, the temperature, the pressure, right? Real-time monitoring, Internet of Things, so another example. Text data, for example, social media data, product review, and customer satisfaction. That Facebook, Twitter, that is now X, actual network, LinkedIn, and many other companies use. Software like data can be used to automatic troubleshooting, right? And the other one is genotype and phenotype data that can be used for patient-centered care or personalized medicine, right? These are other examples that use data science. In general, we can say data science is intersection between math and statistics knowledge, hacking skills, and substantive expertise, right? Actually, hacking skills and math and statistics knowledge provides machine learning, right? Hacking skills and substantive expertise provide dangers, and it's not good. Substantive expertise and math and statistics provide traditional research. Traditional research before having, for example, um, methods in computer science methods. But intersection of these three provides data science. We use all the skills from these different aspects. Now let's learn a little bit about AI. Okay. What is AI? We can have two different definitions for AI. We can say that AI can be defined as the simulation of human intelligence processed by machines, especially computer systems. And these processes include learning, remembering, reasoning, planning, communicating, and interacting with its environment. A system is called artificial, uh, actually can be considered as artificial intelligence system if it can do all at least one of them. Doesn't need to be all of them, at least one of them. For example, remember what it happened, what has happened, right? Or for example, communicating or learning, right? If a system can do all of them, its intelligence is very high. Also, AI can also be defined as a system's ability to correctly interpret external data, learn from such data, and to use those learning to achieve specific goals, right? And or approach the specific goals and task through flexible adaptation. This is another um, definition. We can say artificial general is an umbrella for machine learning and deep learning. Actually, machine learning and deep learning are subsets of artificial intelligence. In general, artificial intelligence includes techniques that enables computers to mimic human behavior, because human behavior in general is intelligent behavior. Machine learning is AI techniques that give computers the ability to learn without being uh, explicitly programmed to do so, which means if you have a machine learning algorithm or method, it can learn from the data that it gathers, can learn and do something new, right? Provide new knowledge, right? Without program to do that, right? And deep learning is actually a subset of machine learning, which makes the computation of multi-layer neural networks feasible. Neural network is, we can say, is a tool that can be used in machine learning. When we have many layers in a neural network, we can have a deep learning model, right? Okay. Again, some different, for example, applications of artificial intelligence, machine learning, and deep learning. Here we have, because we have the short of time, let me go faster. Okay. Actually, Alan Turing, mathematician, British mathematician, provided a test. It is called Turing test, and it says that suppose we have uh, actually system, AI system, and a person, right? And we have a questioner, human question. This guy asks question from uh, both actually respondent, but he doesn't know which one is a human, which one is a computer. If based on their responses, if the human questioner can recognize which one is computer, right? Then the AI of the level of AI of that system is not uh, that much high or can not compete the human um, intelligence, right? But if the human questioner cannot recognize which one is human, which one is computer, it means that the system has a high level of intelligence that is comparable with the human intelligence. And this is the history of AI from when it started all the way to actually recent years that it has advanced and is used in many aspects. For example, autonomous car in mobile apps to recognize. Examples can be examples of using AI, can be Siri or Alexa, Amazon Alexa, right? These are examples of AI algorithms in these applications. Or uh, many robots or drones that, for example, in Amazon is going to use drones to deliver goods, right? So AI is used in that, right? Or in many factories that assemble products, robots that do assembly, they use AI algorithms. So this diagram shows the future of AI actually in term of revenue, right? This is the forecasted cumulative global artificial intelligence revenue from 2016 to 2005 by use case. So for example, you can see in static image recognition, classification, and tagging, the revenue in this area is more than $8,000 million, right? Or actually, for example, for each of these aspects. For example, algorithm, um, trading strategy, performance, and improvement is 705, sorry, more than 7,000 million, right? And so on, right? Or we have, these are not limited to just these fields in many other fields, but this is increasing. And actually, the demand for data scientists is increasing. Almost every company in any field needs data scientists. And this diagram, this is the actually last slide. This shows the impact of AI automation on jobs. Sometimes we think that by emerging AI, by using AI more and more in different fields, we may lose jobs and we may not have enough jobs uh, for our kids, for example, when they grow up. But actually, that diagram shows that the net is increasing because of AI. We will have more jobs, right? The dark blue is the loss, and the light blue is the gain, and the black line is the net. It was decreasing, but after 2018, the net is increasing. So the jobs that are needed because of AI is more than jobs that are lost. For example, when we have uh, taxis with no driver, maybe there is no need for taxi drivers because taxis are autonomous cars, right? But we need experts to maintain the AI systems, to design AI systems, right? Data scientists to get data, to extract data from raw data, right? So we we will have more jobs because of AI rather than losing jobs. Okay, guys, because the time is up, let's finish my talk. Thank you for your attention, and please ask your questions if you have any questions.